Go to the nearest mirror. Right now. I want you to pull your hair back and look closely at your earlobe. Specifically, look for a deep diagonal groove that cuts from the little bump near your ear canal all the way down to the back edge of the lobe. Do you see it? It doesn't look like a soft wrinkle from your pillow. It looks like a scar. It looks like the structure underneath has collapsed. This is called Frank's sign. And if you have it, do not let anyone tell you it is just a part of getting older. Because that little line is the loudest alarm bell your body can ring. For years, mainstream medicine dismissed this. They told you it was just gravity, or that you sleep on your side too much. But when we look at forensic science, actual autopsy data, the story changes. Researchers found this specific crease in 77.1% of patients who died from severe coronary artery blockages. Think about that number. Almost 8 out of 10. If you think this is just a cosmetic issue, you are ignoring a critical signal. Here is the truth. That line on your ear is a mirror. It is reflecting a process happening deep inside your chest right now. We are not talking about high cholesterol today. We are talking about something much more mechanical. We are talking about ectopic calcification. We are talking about a biological identity crisis where the cells in your arteries are confused. They are forgetting they are supposed to be soft, flexible blood vessels, and they are literally trying to turn themselves into bone. Your heart isn't just getting old, it is calcifying. And today we are going to find out why. To understand what is happening to you, we have to stop blaming the wrong suspect. For decades, you have been told that calcium is the enemy. You have been told that cholesterol is the enemy. But that is like blaming the bricks for a bad house. The bricks are just building materials. The real problem is the architect. Deep inside the walls of your arteries, there is a tiny microscopic worker. It is a protein called MGP, matrix GLA protein. Think of MGP as the guardian of the soft tissue. Its entire job, 24 hours a day, is to patrol your blood vessels and kick calcium out. It ensures that your arteries stay like rubber bands, stretchy, flexible, and able to handle pressure. But here is the failure point. MGP does not work alone. It needs a key to turn it on. That key is vitamin K2. Without vitamin K2, MGP remains asleep. It is present, but it is inactive. It is what scientists call uncarboxylated. And when MGP is asleep, the guardian is off duty. Let me give you a visual so you can see this happening inside you. Imagine your bloodstream is a busy highway. Calcium molecules are cars looking for a parking spot. Ideally, you want those cars to park in the garage. That is your bones and your teeth. That is where they belong. MGP is the traffic cop standing in the middle of the highway, whistling and pointing the cars toward the garage. But in your body, right now, the traffic cop is asleep in his chair. He isn't directing traffic. So what do the cars do? They stop right in the middle of the highway. They double park. They block the lanes. In your body, this means calcium starts settling into the walls of your arteries. It crystallizes. It turns into a hard, chalky plaque. This isn't just a clog, it is a structural change. This triggers a biological horror story called phenotypic switching. This is the part that keeps cardiologists awake at night. Your arteries are made of vascular, smooth muscle cells. These cells are supposed to be smart. They are supposed to contract and relax to pump blood. But when they are bombarded by calcium and inflammation, and when the guardian MGP is asleep, these cells suffer an identity crisis. They literally forget who they are. They stop acting like muscle cells and start acting like bone cells. They begin to express a gene called RUNX2, a master gene for bone formation. You heard me correctly. Your artery cells are trying to build a skeleton inside your blood vessels. They are weaving a matrix of bone tissue where there should be elastic rubber. This is why your blood pressure creeps up. This is why you feel stiff. You are trying to pump liquid through a pipe that is slowly turning into a rock. So, why does your earlobe wrinkle? Let's connect the dots. Think of your earlobe like a camping tent. To keep a tent smooth and upright, you need strong, flexible tent poles. In your skin, those poles are made of a protein called elastin. Elastin needs a constant supply of blood and nutrients to stay strong, but remember, your arteries are turning to bone. The tiny microscopic vessels that feed your earlobes, the end arteries, are getting choked off. They are calcifying, the blood flow drops, the tent poles, the elastin fibers, become brittle, they dry out, they snap, and when the poles snap, the tent collapses. The fabric folds over. That deep diagonal crease is not a wrinkle. It is the visual evidence of a structural collapse caused by a lack of blood flow. It is myelastofibrosis, the death of elastic tissue. The terrifying part is the silence. This process doesn't hurt. You don't feel your arteries turning to bone. You don't feel the elastin snapping in your ear. It happens slowly, day by day, for decades. Autopsy studies on the elderly are revealing. They show that nearly 70% of people have significant atherosclerotic plaque, significant hardening, without ever having a single symptom of heart disease while they were alive. They felt fine, they looked fine, until they weren't. That mark on your ear is the body breaking its silence. It is telling you that the traffic cop is asleep, the highway is blocked, and the walls are closing in. But knowing the mechanism is only half the battle. We need to understand the connection. Why does the ear predict the heart so perfectly? The answer lies in a strange biological link called the calcium paradox. This brings us to the pivotal question: why the ear? Of all the places in your body to show a warning sign, why there? The answer lies in the architecture of your plumbing. Your body has a vast network of blood vessels, but they are not all created equal. Most tissues have what we call collateral circulation. This is like having a backup generator. If one road gets blocked, there are side streets the blood can take to get to the destination. But your earlobes and your heart are different. They are fed by what scientists call end arteries. Think of an end artery like a cul-de-sac at the very end of a long neighborhood. There is only one way in and one way out. There are no side streets, no detours. If the road to that cul-de-sac gets blocked by a fallen tree, or in this case calcified plaque, the houses at the end of the street are completely cut off. They lose their supplies, they starve. Your earlobe is that cul-de-sac. It is the furthest outpost of your circulatory system. When your entire vascular system begins to stiffen and calcify, these tiny, fragile end arteries are the first to fail. They are the canary in the coal mine. The deep crease on your ear is a scar of suffocation. It is the tissue literally collapsing because its single supply line has been turned into stone. And this reveals the hidden connection to your heart. The coronary arteries that feed your heart muscle, they act just like end arteries too. If they get blocked, the heart muscle doesn't have an easy backup plan. That is why the ear predicts the heart. If the cul-de-sac in your ear is blocked, the cul-de-sacs in your heart are likely blocked too. This leads us to the calcium paradox. This is the single most important concept for anyone over 60 to understand. You might be dealing with two problems that seem completely opposite: weak bones and hard arteries. Your doctor might treat them as two separate diseases. They give you pills for osteoporosis and different pills for your heart. But the biological detective sees the truth. These are not two different diseases. They are the same problem happening in two different places. It is a distribution error. Remember our traffic cop, the protein MGP? It has a partner in your bones called osteocalcin. Both of them depend on vitamin K2. When you are deficient in K2, both of these proteins fail at the same time. Here is the domino effect. First, the protein in your bones goes to sleep. It can't hold on to calcium anymore. So the calcium leaches out of your skeleton. Your bones get weak, porous, and fragile. Second, that homeless calcium floods into your bloodstream. Third, because the MGP in your arteries is also asleep, that calcium has nowhere to go. It settles into the vessel walls. So, you end up with calcium leaving the place it needs to be, your bones, and attacking the place it shouldn't be, your arteries. You are literally calcifying your soft tissues while your skeleton dissolves. That crease on your ear is the visible proof that this redistribution is happening right now. Now, I know what some of you are thinking. I can hear the skepticism. But I sleep on my right side. That's why my right ear is creased. It's just a pillow mark. Let's bust that myth right now. If this were just about sleeping position, we would expect to see the crease only on one side. But in the vast majority of cases linked to heart disease, Frank's sign is bilateral. It appears on both ears. Unless you have figured out a way to sleep on both sides of your head at the exact same time, the pillow theory falls apart. Furthermore, when pathologists look at these creases under a microscope, they don't see a simple fold of skin. They see internal destruction. They see nerve degeneration. They see the shattered remains of elastin fibers. You cannot create that kind of cellular damage just by laying your head on a pillow. This is biology, not mechanics. So, we have identified the villain, the sleeping MGP. We have identified the crime, the calcium paradox. Now, we need to wake the guardian up. We need to stop the calcification and recover the flow. And to do that, you need to stop doing one thing immediately and start a simple 2-minute habit. If you are ready to reclaim your health, we need to start by clearing out your medicine cabinet. I want you to go to your bathroom sink. If you see a bottle of antiseptic mouthwash, the kind that burns and promises to kill 99% of germs, I want you to throw it in the trash. This sounds counterintuitive, I know. You were taught that killing bacteria is good, but here is the science. Your body relies on a molecule called nitric oxide to relax your arteries. Nitric oxide is what keeps your blood vessels wide open and flexible. It is nature's blood pressure medication. But your body cannot make enough of it without help. It relies on specific bacteria living on your tongue to convert the nitrates in your food into nitric oxide. When you use that harsh mouthwash, you aren't just killing bad breath. You are dropping a nuclear bomb on the bacterial factory that protects your heart. You are literally washing away your body's ability to lower its own blood pressure. So, stop the mouthwash. Let the good bacteria return. Now, let's talk about the hero solution. We need to wake up the traffic cop. We need to reactivate the MGP protein so it can start sweeping calcium out of your arteries and putting it back into your bones. The key is vitamin K2. Specifically, you want the form called MK7. This is the long-acting form that stays in your blood system long enough to reach the tissues that need it most. Vitamin K2 acts as the ignition switch. It turns MGP from inactive to active. It takes the handcuffs off the traffic cop. You can find K2 in specific foods like hard-aged cheeses such as Gouda or Brie. The absolute best source is a Japanese dish called natto, fermented soybeans. But I warn you, it is an acquired taste. For most people, a high-quality K2 supplement is the most reliable insurance policy against calcification. Alongside K2, you need to add magnesium. Think of magnesium as the natural calcium channel blocker. It balances the calcium in your system and prevents it from clumping together. And finally, eat your nitrates: beets, spinach, and arugula. These provide the raw fuel for those bacteria in your mouth to create the nitric oxide that expands your vessels. Finally, I want to give you a simple 2-minute habit you can do today. It is called stop-start walking. If you have poor circulation, or if your legs feel heavy or painful when you walk, a condition called claudication, this is for you. I want you to go for a walk. Walk until you feel a moderate amount of pain or heaviness in your legs, about a 3 or 4 on a scale of 10. Then stop. Rest completely until the pain goes away. Then start again. Why do this? You are using a biological trick. By pushing your muscles to the point of mild discomfort, you are creating a temporary lack of oxygen. This signals your body to release a powerful protein called VEGF, vascular endothelial growth factor. This protein tells your body to sprout new, tiny blood vessels. You are essentially commanding your body to build its own natural bypass roads around the blockages. We have covered a lot today. You know that the line on your ear is a signal, not a scar. You know that calcium is the passenger, but vitamin K2 is the driver. But this brings us to a dangerous crossroads. Many of you are taking vitamin D supplements every single morning because you've been told it's good for your bones. But there is a dark side to vitamin D that almost no one talks about. If you take vitamin D without vitamin K2, are you actually speeding up the calcification of your arteries? The answer might change your entire morning routine, and we are going to uncover that mystery in the next video.